Okay, so for solving quadratics, it's a formula that has x squared in it. It has 2 solutions, and we have 5 ways of solving. Quadratic formula works every time no matter what, but it's not fun and it's not efficient. So we have other methods also. Factoring is a method that is common, but it doesn't always work. Square roots is a method that we use because it's quick and easy. Completing the square, we're going to go over that. It's similar to quadratic formula. And then substitution is, you don't use substitution very often. I might even say like 10% of the time. But it's really helpful on those problems that we are going to use it on because it's difficult to do those any other way. Okay, so I'm going to give you a problem and we're going to work it out all the ways. Okay, I'll give you a different problem because there's problems that are more geared towards one than the other. So let's start off with quadratic formula. We've already done quadratic formula before, so this should just be a review at this point. But a good quadratic formula problem, let's do this one. 3x squared minus 4x equals -1. And we are going to solve this using the quadratic formula. To use the quadratic formula, it has to equal 0. Oh well, that's the wrong problem. That's okay. It has to equal 0. Okay, so does this problem currently equal 0? No, let's make it equal 0. So I'm going to add 1 to both sides, and I get 3x squared minus 4x plus 1 equals 0. Okay, so to plug it in the quadratic formula, what's my a value? What's my b value? What's my c value? 1. So a is 3, b is -4, c is 1. Let's plug it in. Quadratic formula is, if you forgot, plus or minus the square root of b squared minus 4ac, all divided by 2a. It's funny that I don't really like the quadratic formula, and my class before this and my class after this, we're also doing quadratic formula, so I'm doing like for 3 hours. Kind of tired of it at this point. Okay, so let's plug it in. We plug in b, it's -b, so that means change the sign of b. So it'd be +4 plus or minus the square root of -4 squared minus 4 times my a value is 3, my c value is 1, and all of that, even the 4 at the beginning, is divided by 2 times 3. You work out the inside of the radical. -4 squared is always going to be a positive number. In this case, it is +16. -4 times 3 times 1 is -12, so it's going to be 16 minus 12. What is 16 minus 12? 4. So this problem becomes 4 plus or minus the square root of 4 divided by 6. Can I take the square root of 4? Yes, if you can, you go ahead. If you can't, you see if you can simplify it, leave it like that as your answer, right? Or if it had a negative in it, pull out the negative as an I. Okay, in this case, we can take the square root of 4. What is the square root of 4? 2, good job. So 4 plus or minus 2 divided by 6. And that's 2 problems right there. One of the problems is 4 plus 2 divided by 6. The other is 4 minus 2 divided by 6. 4 plus 2 is 6, and 6 divided by 6 is 1. 4 minus 2 is 2. 2 divided by 6 is 1/3. So there are your 2 answers. We've already gone over this, but just a reminder, sometimes your 2 answers could be like 4 plus or minus the square root of 5 divided by 6. And the 2 answers, one of them is the plus, the other is the minus. It could also be 4 plus or minus I times the square root of 5 divided by 6. One's plus, one's minus, okay? So lots of different options there. If you end up with 2 pretty numbers, what does that tell you about your original quadratic? You know? It means you could have factored it. You didn't have to do quadratic formula there if you didn't want to. Okay, so if you end up with 2 nice numbers, that means I could have solved that by factoring. So let's do that. Let's do that same problem, but this time let's solve by factoring. Okay, so same problem, 3x squared minus 4x plus 1 equals 0. How am I going to factor this? AC method, my A value is 3, B is -4, C is 1, A times C is 3 times 1, which is 3. Two things that multiply to give me 3 are 1 and 3. How am I going to make them add to be -4? -3, -1. So you go and plug that back in your problem. This is not a shortcut problem, so I have to factor by grouping. 3x squared minus 1x minus 3x plus 1. You could switch the 3 and the 1 if you wanted to. It doesn't matter. When you factor by grouping, the first two, 3x squared minus 1x, they have a greatest common factor of x. Left over is 3x minus 1. The last two have a greatest common factor of just 1, but since the first thing is negative, you need to take out a -1. -3x divided by -1 is positive 3x. 1 divided by -1 is -1. And now they have the 3x minus 1 in common. Left over is x minus 1. How am I going to solve for x now? Set your factors equal to 0 and solve. So 3x minus 1 equals 0. X minus 1 equals 0. Add 1, divide by 3, and you should get 1/3. Add 1, and you should get positive 1. Questions about that? Okay, so for that problem, it didn't matter which method you used. You could use quadratic formula or factoring. Does anybody prefer quadratic formula over factoring? I'm crazy. I'm just joking. I think it's just what you're comfortable with. If you like to factor, then I like to factor. That's what it comes down to. I don't like quadratic formula, but quadratic formula always works. If this were a problem that had an A value of 1, it would be a lot faster to factor it. If this A value was 1, x minus 1, x minus 3, my answer is positive 1, positive 3, right? It would be so much faster for factoring. So when A is at 1, I think you could argue it's probably the same amount of time either way. Okay, so that's solving by factoring quadratic formula. Now let's talk about square roots. Okay, so let's do a couple of problems with square roots. If I had the problem, this is number 3, 5x squared minus 55 equals 0. We are going to solve this problem using square roots. Could you solve this problem by using the quadratic formula? Yes. What's your A value? 5. What's your B value? 0. There's not a BX here. And what's your C value? Negative 55. Plug it in, you'll get 2 answers. Okay, that's one way to do this. To solve this by factoring, you'd factor out the 5, but then it's the difference of 2 squares and it's not a perfect square, so it's kind of a mess. So you couldn't really solve this one by factoring very easily. So instead, using square roots, to solve using square roots, you just solve for x. So the first thing you would move is the 55. How do you move the 55 over? Add 55 to both sides. And I get 5x squared equals 55. What's the next thing I'm going to do to solve for x? Divide by 5. And I get x squared equals 11. How do I solve for x now? Take the square root, and there is a rule that you may or may not have remembered. Is there a square root in this problem right now? No, there is not a square root in this problem. I am going to put a square root in to solve it. So if you use a square root to solve, you have to put in a plus or minus. And the reason why is right now, before I take that square root, whatever the answer is that I plug in for x there, that could be a positive number or a negative number, right? Because when you square it, the sign goes away. Like they both become positive. So Because of that, if I'm going to use the square root to solve, I have to put plus or minus the square root. Okay, that's what also gives us our second answer. If you would not have put the plus or minus, you'd only have one answer here, and we know there has to be two answers. Okay, so the square root of x squared is just x, and x is plus or minus the square root of 11. I can't take the square root of it. I can't simplify it, so those are my two answers. You could leave it like that, or you could write positive square root of 11, negative square root of 11, which is what Math Lab will want you to do. Questions about that? Okay, so I would say that one's a lot quicker and easier than doing quadratic formula, at least for sure. Let's look at the next one. Again, remember you can only do square roots when you don't have an x term, when it's just an x squared term in your problem. Let's do completing the square. Yay, completing the square. Let me find a problem for it real fast. Here we go. We're going to do a couple of these because I'm thinking it might have been a minute since you've done this kind of problem. Solving by completing the square. X squared minus 2x equals 2. Okay, to solve by completing the square, basically what we're trying to do is we're trying to make the left-hand side here, x squared minus 2x, factor into a perfect square, into x plus or minus something with a square on the outside. Once we have it factored like that, we can just take the square root of both sides and solve it. So I have to add this perfect number in there to make it work. So what I'm going to do first is rewrite the problem, and I'm going to put a blank there. X squared minus 2x plus blank. I'm going to add a number there in a minute. Equals 2. I can't just add something on the left-hand side to keep my equation equal. I have to also add whatever's in the blank on the right-hand side. Okay, so you could sit here and guess and check. You could plug in the number 5 and see if that factors perfectly. You could plug in the number 10 and see if that factors perfectly. You might be here for a while because there are infinite numbers you could plug in there, right? So I have a formula that tells me the perfect number to plug in to make it factor perfectly, and it's b divided by 2 squared. Okay, so in this case, my b value is negative 2. Negative 2 divided by 2 is, I'm sorry, yeah, negative 2 divided by 2 is negative 1. And what's negative 1 squared? Good job, you got it, 1. Okay, so that's the number that goes in the blank. I put a 1 here and a 1 here. So b divided by 2 is what goes in the blank. So now the left-hand side factors perfectly. You could factor it. A times c is 1. What do you think is multiply to get 1, add to get negative 2? Negative 1, right? I could do this on a different sheet of paper if I needed to. Let's see. Yeah. A times c is 1. It needs to be negative 1 and negative 1. So then my factors would be x minus 1, x minus 1. You could also write that as x minus 1 squared, right? That's one way to do it, is sit here and factor it out and see what it is. The shortcut for it is it's always x, it's in a parentheses, it's always squared. This minus 1 right here was the number before you squared it. It's just b divided by 2. Okay, so it always factors into x plus b divided by 2 squared. In this case, the b divided by 2 is negative. Equals, what is 2 plus 1? 3. Okay, so the whole point of completing the square is now I have a perfect square on the left-hand side. How do I get rid of the squared? Take the square root of both sides, and don't forget it's plus or minus the square root. So what is the square root of x minus 1 squared? Just x minus 1 equals plus or minus. Can I take the square root of 3? No. Can I break it down? No, it's just plus or minus the square root of 3. How do you solve for x now? Add 1 to both sides. And when you add 1, stick it up in front of the plus or minus. So I get x equals 1 plus or minus the square root of 3. When your answer looks crazy like that with the square root, that means you could not have factored that problem. That is not a factorable problem. If you would have solved using the quadratic formula, you would end up with the same answer here. Okay, completing the square and quadratic formula are very similar. The way, if we have time, let's kind of do it all the way. I was gonna say I can show you how you come up with the quadratic formula completing the square. We'll see. Let me think about it for a minute. So go ahead and do one more of those, completing the square. X squared minus 6x minus 11 equals 0. Let's do plus 6x. If you have your C value there, you got to move it over to the other side to make room for your blank. Okay, so add 11 to both sides. Equals 11 plus blank. Okay. Okay, so when you do this, you do b divided by 2 squared. My b value in this case is 6. 6 divided by 2 is 3, and 3 squared is 9. So 9 is the number you add to both sides. Everybody got that? Then you factor this. You could factor it using the AC method, or the shortcut is it's always x in parentheses squared. Here it's the number before you squared it, just b divided by 2, which in this case is positive 3. So x plus 3 squared equals 11 plus 9 is 20. And then to solve for x, take the square root of both sides. Don't forget your plus or minus. So I get x plus 3 equals 20. I can pull a 4 or pull 2 out, right? 20 is 2 times 2 times 5 when I break it down. So I can pull the 2's out. So it becomes plus or minus 2 times the square root of 5. And how do I solve for x now? Minus 3 from both sides, and it goes up in front of the plus or minus. So I get negative 3 plus or minus 2 times the square root of 5. Questions about that? You good with completing the square? I've told you it works 100% of the time. It does technically work 100% of the time, but you would only want to use it when your A value is 1, okay? So you really only want to use it when A is 1. The reason why technically it could work every single time is you could divide by whatever your A value is, but then you would probably have fractions in there, and then you're doing all this stuff with fractions, and it's kind of a mess. So technically you still can do it that way, but you really only want to do it when A is 1. Okay, so I'm going to take a couple minutes and I'm going to show you where the quadratic formula comes from. So how did we come up with the quadratic formula? By completing the square. Okay, you do not have to write this down. If you're watching this and you're like lost and you're like, I don't even care about this, that's totally fine. This is for the people who are interested in where formulas come from. Okay, so this is if I have some random quadratic of ax squared plus bx plus c equals 0. I'm going to solve that by completing the square. There are no numbers here. Okay, these are all letters, so it's going to be might be a little confusing, but it's just using basic algebra. Okay, so I said that your a has to be 1 here. So the way to fix that problem, if you have an a value, is to divide every single thing by a. So I end up with ax squared divided by a would just be x squared, right? If I divided by bx divided by a, the numbers would just be the b and the a. So it'd be b divided by a times x plus c divided by a equals 0. Everybody good? Okay, if I want to complete the square, this number needs to move over to the other side. And I want to put blank there. So I'm going to subtract this c divided by a from both sides. So I get x squared plus b divided by a times x plus blank equals negative c divided by a plus blank. How do I fill in the blank? This middle term divided by 2 squared. Okay, so that middle term, I'm going to do it over here, that b over a, when I divide it by 2, that's like multiplying by 2 on the bottom. Okay, and then I need to square it. So let me do that. B squared would just be b squared. 2 squared is 4. A squared is a squared. So that's the number that goes in the blank. B squared over 4a squared. Okay, so now the next step for completing the square is factor this. This is where you want that formula, right? Because I don't want to have to like figure out what two things multiply to get this and add to get that. Okay, so this factors into x plus this thing before I squared it would be b over 2a squared equals, here I want to add these two together. You have to get a common denominator to add fractions together. So to get the common denominator, I would need to multiply the bottom and the top by 4a. So this would be negative 4a times c is negative 4ac. That's kind of starting to sound familiar, right? Over 4a squared plus b squared over 4a squared. So now they have a common denominator, so you can just add across the top and keep the bottom. So I'm going to rewrite it. X plus b over 2a all squared equals, when I add across the top, negative 4ac plus b squared, I'm going to write it as b squared minus 4ac over 4a squared, right? Now take the square root of both sides. So square root this side plus or minus square root that side. So over here on the left-hand side, I just get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 4a squared. When I take the square root, what's the square root of 4? 2. And what's the square root of a squared? A. How do you solve for x now? Subtract that. So I'm going to subtract b over 2a from both sides. And I get x equals, you could write it negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Or do they have a common denominator? Yes. So you can put it all together. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so quadratic formula comes from completing the square, just with letters, and so that you can plug your letters in there. Okay, so that was for anybody who's actually interested in that. That may not be anybody, so just a little extra for you. The last way, so we've talked about quadratic formula, factoring, square roots, completing the square. The last way we're going to talk about factoring is substitution. Again, substitution does not happen very often, but when it does, it's very, very helpful. We use substitution when something doesn't exactly look, it's not exactly a quadratic, but it looks a lot like one. Okay, so, sorry, I'm trying to find, here we go. For example, no, that's not it. If I had the problem, x plus 1 squared plus 4 times x plus 1 plus 3 equals 0. Okay, we could work this problem out. We could do x plus 1 squared. We could distribute the 4. We could then combine like terms, and then we just have a regular quadratic that we could choose to factor, quadratic formula, however you want to solve it. Or doesn't this kind of look like a quadratic already? Doesn't it look like something squared plus 4 times something plus 3? So let's pull this something out and stick a letter inside of it to make it a little bit easier. So I'm going to pick the letter A. I'm going to say, let's let A equal x plus 1. So if A equals x plus 1, I can rewrite my problem much easier. Instead of it being x plus 1 squared, now it's just A squared. You know, I probably shouldn't have picked A. Let's pick a different letter. Let's make that a P. You'll see why in a second. The reason why I shouldn't have picked A. So this would be P squared plus 4 times P plus 3 equals 0. Doesn't that look like a regular old quadratic? Yeah. So I can solve this factoring, quadratic formula, completing the square. I cannot use square roots here because I have the B value right there, right? How do you want to solve it? Yeah, factoring is the easiest way to solve this because this is the reason why I didn't use the A. What's my A value here? The number in front of P squared, right? A is 1, C is 3. A times C is 3. What two things multiply to get you 3? 1 and 3. Do they add to give you 4? Yeah. My A value is 1, so it's a shortcut problem. So this factors into P plus 1 times P plus 3. How do I solve? Set it equal to 0. P plus 1 equals 0. P plus 3 equals 0. At some point, you have to substitute your x plus 1 back in because I want to find x. I don't care what P is. I want to know what x is. You could substitute it back in here, or you could solve for P first and then substitute it in. It's up to you. It doesn't matter. I'm going to go ahead and substitute back in here. So I'm going to stick x plus 1 back in for P on both of these. So this becomes x plus 1 equals 0. X plus 1 plus 3 equals 0. What's x plus 1 plus 1? X plus 2 equals 0. To solve for x, subtract 2. You get x equals -2. Same thing here. X plus 1 plus 3 is x plus 4 equals 0. Subtract 4. You get x equals -4. Questions about that? So do you see how you take a problem that looks a lot like a quadratic, turn it into an easy quadratic, and then put your weird part back in to make it a lot easier? Let's do one more like that. If I had the problem, it's not exactly like that. It's a substitution problem. If I had the problem x to the 4th minus 7x squared plus 10 equals 0. That kind of looks like a quadratic, right? It's not because it has x to the 4th power, but doesn't it look like a quadratic? Yes, because I have something squared minus 7 times something plus 10. What's my something? What's my P or my Q or my R or whatever you want to call it here? Yeah, x squared is the, let's do R this time. R equals x squared in this case. Because x squared, when I squared it, I get x to the 4th, right? So this now is r squared minus 7 times r plus 10 equals 0. You can factor this using the AC method. A times C is 10. What two things multiply to give me 10? 1 and 10, 2 and 5. Which one's going to give me -7? -2, -5. So that tells me that this factors into r minus 2, r minus 5. How do I solve for r? Set factors equal to 0 and solve, right? So I get r minus 2 equals 0, r minus 5 equals 0. Let me substitute back in now. Instead of r, I don't care what r is. I want to know what x is. So I'm going to put x squared back in now. So this is x squared minus 2 equals 0. X squared minus 5 equals 0. How do I solve for x? Add 2, add 5, take the square root, right? So add 2, I get x squared equals 2. Take the square root of both sides. Don't forget your plus or minus. I get x equals plus or minus the square root of 2. Sorry, I'm running out of room. I'm trying to squish it all on one paper. Add 5 to both sides. X squared equals 5. Take the square root of both sides. I get x equals plus or minus the square root of 5. How many answers do you have there? 4. 2 right here with the square root of 2. 2 right here with the square root of 5. Look at your degree. What's your highest exponent? 4. You're supposed to have 4 answers here. Okay, so as you move through more math classes, substitution becomes more and more common. In this class, we honestly don't do much substitution. But this is like whenever you have like trig functions or when you have some weird things in calculus, you can relate it back to a quadratic and use the idea of solving a quadratic to solve for it. Questions about that? Okay, so I will go ahead and give you a heads up. For this week, I really need you focusing on exam number 1. Like you've got to do well on exam number 1. Incentive to try to do well on exam number 1 is your final exam is optional for this class. Your final exam, if you're not happy with an exam grade, you can substitute it back in. But if you're happy with all your exam grades, you don't have to take the final. The final is a beast in here, okay? So I don't create it. The person who does it for all the college algebra. So that is a strong encouragement for you to study for your exam number 1. If you study that review that I created and you can do every problem on that review that I created, you should be totally fine for the exam, okay? So this week we're focused on exam number 1. After you take exam number 1, if you cannot factor, the whole unit is going to be awful, okay? So if you're not great at factoring and you need some practice, after you finish exam number 1, start focusing on factoring. And if you need some extra videos, I have videos that I can send you of how to factor starting from the beginning, like breaking it down super slow, okay? So I will see y'all on Wednesday. If you need an extra copy of the review, come see me.